Hello, my name is Ritisha Kiran, and today I will be going over Module 6, Question 3 for the Logistic Regressions and Assumptions section of this class. So the objective for this question today is to build a model that includes age, gender, and different factors to test the outcomes that can be used reliably to diagnose COVID-19 without lab-based testing. Today, we will be evaluating how different data combinations predict PCR confirmed for COVID-19. We will be using different factors such as home test results alone, age, gender, and their interaction, symptoms added to the above, and pair of symptoms added to the full model. We will make sure to report the percent of variation included at each step, which is the McFadden R-squared value, and we will be identifying the most accurate method for at-home diagnosis through the use of different informatics skills. Overall, we will be able to assess whether clinicians can make such predictions without having the proper algorithmic aid. So for the first model that we have today, which is question 1, we will be creating a model that includes only home test results as the independent variable. So for this, we are now asked to build a logistic regression model that predicts whether someone tested positive on a PCR COVID test based solely on their home test results, which can be positive or negative. And then we will be calculating the McFadden R-square here, which I was able to calculate. So first we'll go ahead and go to our code here. So for question 1, I've loaded the different required libraries that we need here, library readr and library dplyr. I'm first going to go ahead and read the data set from the downloads folder right here, and then I'm going to be cleaning and renaming the relevant variables. So right here, I have the PCR positives for the two different. I'm renaming two important columns to easier names. So the PCR result, whether the PCR test was positive 1 or negative 0. And the home test result, test 0, positive 1. Next, for step 3, I'm keeping only the necessary columns and dropping rows with missing values as they won't be able to show me if the person has the COVID or they don't. And for step 4, I will be using the GLM code to make sure I'm able to create the proper logistic regression model with all the data that I have. And then I'll go ahead and print the summary of the model. And then I will be able to calculate the McFadden pseudo R-squared using this formula right here, which is null deviation minus residual deviation divided by null deviation. Which is null deviation. Okay, and then now just going back here, I was able to get my regression model right here, and it gave me all of the proper values that I needed for this part. This model helps determine how useful at-home test results are at predicting it for the independent variable. And here is my R code right here, which gave me the data and the regression model needed. Okay, and now we are on question 2. So I will be building a model this time that includes age and gender and interaction of age and gender with the home test results as independent variables. So this time we will be predicting PCR test positivity based on different independent variables, which include the age, gender, interaction of age and gender, and the home test results. This model performs better than a model with no predictors, and it indicates these variables provide meaningful insights into COVID-19 PCR outcomes. So for question 2 right here, I'm installing the package I need and then loading other packages that were previously installed in question 1 right here. Then I'm loading my data set, which was given in the prompt, which is the CSV, cleaning and preparing all of my data, making sure I have the gender and then my 2 positive um, PCR tests. I'm going ahead and naming the gender and the positive PCR test, filtering the gender as well. Going ahead and running my logistic regression model, getting my model summary and my deviance results, along with my McFadden R-squared value. So over here, I was able to show that my percent variation explained McFadden R-square, and I was able to get 26% of the variation in the log odds of testing positive is explained by this model compared to a model with no predictors. So this suggests a moderately strong model, particularly driven by age and possibly the interaction with gender. Finally, the deviance residuals ranging from negative 1.91 to 2.68 indicate how far each individual prediction deviates from the actual outcome, which is useful for model fitting. Okay. And now we have question 3 here. Okay, let me just pull up the stuff for question 3 right over here. Okay, for question 3, we'll be predicting the age and gender, interaction of age and gender, home test results, and symptoms as independent variables. I'm trying to find the stuff for this right here. Here we're considering all of these factors, home test results, and all reported symptoms used. And here are the significant predictors that I got while testing these different ones. Okay, and then right here, question 3, I'm loading previous libraries, reading the CSV file, cleaning all of the data here, and making sure I add all the different symptoms for COVID. I have fever, cough, runny nose, fatigue up here. Then I'm making sure I have all the symptoms added, as well as my McFadden R-squared at the end. Okay. Over here, I was able to get a value of 57.39% of variance in the log odds of the outcome by the predictors in the model. And based on the output, I was also able to measure the 3 different predictors, which were important signs: difficulty breathing, loss of balance, and loss of taste, which were the 3 most important symptom predictors for COVID. And then for our final model, I'm going to go ahead back here. For our final model, I will be using both the COVID care CSV file, which contains patient level data, and the pairwise of the 2 symptoms occurring together. Each cell show how many patients had both symptoms at the same time. So this is a very complex model, which would be really beneficial for healthcare clinicians. And then I was able to get my regression table for this, which is now my final code, loading all of my values, then making sure I load both the data tables this time so I can see patients who had both symptoms at the same time, which is more of a complex situation. I'm adding different interaction terms, selecting symptom columns, that I'm processing symptom matrix into flat features. Okay. And then I'm fitting the logistic regression model and then the null model for McFadden's R square and calculating it overall. So I was able to get the highest percent of 76.23% of the variability in this test right here. Okay. This is my regression model. So one of the last questions is, what is the most accurate way to be able to diagnose COVID-19 at home before clinic strategies are used? So we used multiple different ways: home test results, demographic data, symptoms, and symptom interaction patterns between multiple patients. And our final model, which we were able to find interaction patterns, was our strongest model, which is the 76% McFadden R squared, which was the model for. And this suggests that home-based screening using symptom checklists and test results can closely approximate PCR outcomes. And a combined approach using both of these offer the most accurate at-home diagnosis prior to clinical triage. Lastly, we just wanted to go over clinical use and feasibility and discuss whether a clinician can make such a complex diagnosis by using such a type of system. And I believe that these models are very complex and have a lot of interaction terms that can get in the way of a clinician and their judgment. And these tools can supplement for a clinician's expertise rather than replacing it. And I do believe that over reliance on these types of models can get in the way of clinical judgment and lead to medical errors, which are not safe to use with real life patients. We can use this and see this as a balanced approach, which is essential for safe and effective use. I do believe that human judgment will always take place in front of different AI tools, and these AI tools are used to help and not serve as expertise for critical care. Thank you so much for watching my video. If you have any questions, please comment down below. And all of my work was checked with ChatGPT, and I used RStudio to come up with all of my results and my variance percentages.